Hello, my dear students. Today we are going to start chapter 5, which is organic chemistry. Today we are going to discuss the concept of organic chemistry, and we are going to discuss the differentiation between the organic compounds and inorganic compounds, and we are going to discuss the concept of hydrocarbons and the types of hydrocarbons, and then we are going to discuss the nomenclature of hydrocarbons. So let us start. Organic chemistry. The vital force theory of Berzelius in 1806. It states that the organic compounds are formed only under the vital force found in the living cells of the body. Berzelius divided the compounds into two types: organic compounds, which compounds extracted from animal or plant origin, and inorganic compounds, which are compounds originate from mineral sources in the earth. Wohler, this scientist, proved that the vital force theory was false, as he could prepare urea, which is separated from urine, by heating aqueous solution of ammonium chloride and silver cyanate. As the equation proceeds on the screen, ammonium chloride solution plus silver cyanate solution, it gives silver chloride and ammonium cyanate. Here, ammonium cyanate solution by heating gives urea, which is organic compound. So we have good reason in this point. The failure of vital force theory to explain the formation of the organic compounds. Because Wohler prepared urea, which is separated from urine, that is organic compound, in the lab, by heating aqueous solution of two inorganic compounds that are ammonium chloride and silver cyanate. As the equation proceeds on the screen, ammonium chloride solution plus silver cyanate solution, it gives silver chloride and ammonium cyanate solution. Here, and on heating ammonium cyanate, it gives urea, which is organic compound. So we have another give reason in this point. Organic materials known according to their structure, not their source. Because most of organic compounds are prepared in lab and are not formed in living organisms. My dear student, notice that organic chemistry is the study of carbon compounds, with the exception of carbon oxides, carbonate, and cyanide salts. My dear student, notice that the ratio between the organic and inorganic compounds is approximately 20:1. So we have good reason in this point. Organic compounds are abundant. This is due to the ability of carbon atoms for linking together in several ways: single or double or triple bonds, or straight chain, or branched chain, or cyclic chain, or another elements such as nitrogen or oxygen or hydrogen share with carbon atom, and also the ability of joining their molecule with each other to form large molecules that we call polymerization process. My dear student, the name of the organic compounds is according to their Latin numbers of the carbon atoms. So here 1 means meth, 2 eth, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec, 11 on deck, 12 dodec. First, here, my dear student, we are going to discuss the molecular formula of the organic compounds. What do you mean by molecular formula? It is the formula that shows the type of atoms and their number in one molecule. For example, my dear student, the molecular formula here for ethene or ethylene is C2H4. Show the number of atoms and the type of atoms in the molecule. Here the structure formula. It is the formula that shows the type of atoms and their number in one molecule and the kind of linkage between the atoms in the covalent molecule. For example, the structure formula of ethylene, that its molecular formula is C2H4, its structure formula as shown in the screen, C double bond C, and each carbon atom is joined by two single covalent bonds to two hydrogen atoms. My dear student, the structure formula of organic compounds depend on the valence of carbon is 4, so the carbon atom forms 4 covalent bonds, and here we have 4 single covalent bonds as shown on the screen, or 2 single bonds and 1 double bond, 1 single bond and 1 triple bond. And here, my dear student, more than one carbon atom may link it together by single or double or triple bond. So, the molecular formula and structure formula for some examples. C2H4Cl2 molecular formula can be shown as the screen show. C and C single bond, CCl each single bond, and C and 4 hydrogen atom by single bond. Also C2H4, here C and C by double bond joined together and 4 CH bonds single bonds. And C2H2, C and C have triple bond between them and 2 CH bonds single bonds. And CH3OH, here carbon joined to 3 hydrogen atom by single bond, and carbon oxygen single bond and OH single bond. So they show the difference between the molecular formula and the structure formula. The molecular formula show the number and type of atoms only in the molecule, while the structure formula show the number and the type and the arrangement of atoms in the molecule to show the type of bond or type of linkage between the atoms. Now we are going to discuss the types of cyclic organic compounds. Homocyclic compound. It is cyclic organic compound in which all the corners of the ring have carbon atoms only. As shown on the screen, it is homocyclic compound. All the corners of the cycle is carbon atoms. While heterocyclic compounds, here the cyclic organic compound in which the corner of the ring have carbon atoms and other atoms different elements. As shown on the screen, here one nitrogen atom in the ring between the carbon atoms, so it is heterocyclic compound. Now we are going to discuss what is meant by polymerization process. It is a combination of more than one simple molecule of organic compound. These single molecules called monomers and forming large molecules called polymers. For example, trimerization of acetylene. As shown in the screen, 3C2H2 by heat and presence of nickel as catalyst gives benzene C6H6. Here we are going to discuss another concept, which is isomerism. Here they are compounds having the same molecular formula but different structure formula, so they differ in the physical and chemical properties. Examples for isomerism or isomers of different compounds. C2H6O, which is molecular formula, can be drawn into different structure formula forming different isomers. As shown on the screen, CH3CH2OH, which is ethanol, or CH3OCH3, which is dimethyl ether. Another example, C5H12. As shown on the screen, all the carbon-carbon bonds are a straight chain. Here C5H12, or we can make another form of C5H12. We have 4 carbon atoms and 1 carbon is branched, as shown on the screen, and may be drawn into another form with that we have 2 carbon atoms on branch and 3 single carbon-carbon bonds here joined to each other. So we have good reason in this point, my dear students. The structural formula is preferred rather than the molecular formula to express the organic compound. The reason for that is there are many organic compounds having the same molecular formula but different structural formula, and so they differ in the physical and chemical properties. Now, my dear student, we are going to make a comparison between the organic and inorganic compounds. As shown on the screen, the organic compound carbon atom is an essential element. In organic compound, carbon atom is not essential. Here, the organic compounds have low melting and boiling points, while inorganic compounds have high melting and boiling point. Organic compounds have characteristic odor, while inorganic compounds, most of them are odorless. In organic compounds, liquids are inflammable, and when they burn gives carbon dioxide and water vapor, while the liquids of inorganic compounds are non-flammable in mostly. Organic compounds, mostly they are insoluble in water and soluble in organic solvent, while inorganic compounds mostly soluble in water and insoluble in organic solvent. As we know, my dear student, like dissolve in like, non-polar compound dissolve in non-polar combined, while polar compound and ionic compound dissolve in polar solvent. Next point here, the organic compound don't conduct electricity, as we know that covalent compounds don't contain ions, while the inorganic compounds, their solution or fluids conduct electricity, as the ionic compounds can give free ions on their solution or molten state. The organic compounds form huge number of compounds as they show polymerization process, while inorganic compounds polymerization process is not known. In the organic compound, their rate of reaction is slow because it takes place between the molecules, while in organic compound the rate of reaction is fast because it takes place between ions. The organic compounds have isomerism process, while inorganic compounds don't have isomerism process. Here, my dear student, to know the compound is organic compound, we have to detect the presence of carbon or hydrogen in it. Here, for experiment, heat the organic compound with copper oxide in test tube as the following animation show. My dear student, here we bring a piece of plastic and we are going to heat it with copper oxide, and then we are going to show does it contain carbon and hydrogen, so it will prove that the organic compound contains carbon and hydrogen. And here, after burning it, we find that the water vapor is produced and turns white anhydrous copper sulfate into blue. That indicates that the compound contains hydrogen, so it is organic compound. And here we find that carbon dioxide gas is evolved, and we can test the presence of carbon dioxide gas by passing it on lime water. If it turns milky due to formation of calcium carbonate, which is insoluble in water, it means the compound contains carbon as evolving of carbon dioxide gas on the reaction with the carbon and the compound of copper oxide that reduce copper oxide into copper, and the carbon dioxide gas is formed. So the presence of carbon and hydrogen in compound indicate that the compound is organic compound, and here the reaction show that the compound contain carbon and hydrogen, so it is organic compound. So my dear student, how can we draw this experiment? As shown on the screen, the organic substance heated with black copper oxide, and here the water vapor produced turns white anhydrous copper sulfate into blue, and the carbon dioxide gas produced turbid lime water. So the observation here, white anhydrous copper sulfate changes blue due to the presence of water vapor, and 2 hydrogen here reduce the copper oxide into copper and releasing water vapor, and the lime water turns milky due to the presence of carbon dioxide gas, and we are going to show it as the following animation show. As shown on the screen here, my dear student, by heating the carbon compound, the carbon dioxide produced and turbid the lime water as formation of calcium carbonate, which is insoluble in water, turbid it. So heating the carbon compounds or the organic compounds, the carbon inside it will combine with oxygen, forming carbon dioxide gas, the turbid lime water, and so here formation of calcium carbonate makes it white precipitate. So as the equation proceeds, my dear student, carbon plus copper oxide reduces the copper oxide into copper and carbon dioxide gas is produced. Now, my dear student, we are going to discuss the hydrocarbon compounds. These hydrocarbons are organic compounds which contain carbon and hydrogen only, and they are classified into 2 types, aliphatic and aromatic compound. So, my dear student, aliphatic compound can be classified into open chain compound or saturated cyclic compound that we call cycloalkane. And here cycloalkanes or saturated cyclic compound have general molecular formula CnH2n. For example, cyclohexane C6H12, cyclopentane C5H12, and the aromatic hydrocarbons here unsaturated cyclic carbon compounds linked by alternated single and double bond, as benzene here C6H6 as shown on the screen. Here, my dear students, the open chain hydrocarbon can be classified into 2 main types. Saturated hydrocarbons that called alkane or paraffins have general molecular formula CnH2n plus 2, for example methane CH4, ethane C2H6, propane C3H8, and the another type of open chain hydrocarbon which is unsaturated hydrocarbon that can be divided into 2 types, alkenes or olefins that have general molecular formula CnH2n, for example ethylene or ethene C2H4, or propylene propene C3H6, and butene C4H8. And the second type of unsaturated open chain hydrocarbon which is alkyne or acetylenes have general molecular formula CnH2n minus 2, for example acetylene, ethine C2H2, or propyne C3H4, and butane C4H6. Now, my dear student, we are going to make a comparison between alkane and the alkene and the alkyne, paraffins, olefins, and the acetylene. In the type of compound, alkanes are saturated hydrocarbons, alkene and the alkynes are unsaturated hydrocarbons. Here is the type of bond. Here all the bonds in alkane sigma bonds, in alkene all sigma except 1 pi bond, in alkyne all sigma except 2 pi bonds. And the general formula here CnH2n plus 2 for alkane, CnH2n for alkene, and CnH2n minus 2 for alkyne. And the suffix here ending the word of the name of the alkane, ane, alkene, ene or ylene, and alkyne yne, and the chemical activity for alkane is inactive, alkene active, and the alkyne is very active compound. Here, my dear student, we are going to discuss the first member of alkanes. Here the name and the formula. Methane here has formula CH4 as the applying the general molecular formula CnH2n plus 2, so C1 H2 times 1 plus 2 equal 4, and ethane it will be C2H6, and propane C3H8, and butane C4H10. We have give reason for this point. Alkane and cycloalkane are saturated compounds. We have to say because all bonds between carbon atoms are single covalent bonds. And another give reason, alkene and the alkynes are unsaturated compounds. We have to say because the presence of double bond in alkene and the triple bond in alkyne between the carbon atoms. Now we are going to discuss a concept that we call homologous series. Homologous series means compounds having the same general molecular formula and chemical properties and graduated physical property, and each compound exceeds the previous one by CH2 group, which is called methylene group. Now we are going to discuss what do we mean by radicals or atomic group. They are monovalent organic groups that can exist alone by removal of one hydrogen atom. They are alkyl radicals are, and they are alkanes that lost one hydrogen atom and the suffix ane is replaced by yl. For example, methyl comes from methane by removing ane and replacing yl methyl, and ethyl C2H5 by removing ane and putting yl, so it will be C2H5 will be ethyl. Here, my dear student, we are going to discuss the alkane and their radicals, which are alkyl. Here, the general formula CnH2n plus 2, here CnH2n plus 1 by losing one hydrogen atom. So, butane, it will be C4H9 butyl, and ethane, removing one hydrogen atom, it will be C2H5 ethyl. And propane, C3H8 will be C3H7 propyl, and butane C4H10 it will be C4H9, and pentane C5H12 it will be C5H11 pentyl. My dear student, now we are going to discuss the second type of radicals, which are aryl radicals that come from aromatic hydrocarbons. The benzene here C6H6 that loses one hydrogen atom, it will be phenyl C6H5. Now we are going to discuss the nomenclature of organic compounds that we call IUPAC system, which is abbreviated from International Union of Pure and Applied Chemistry. So the name of the hydrocarbon is determined according to the following rules. The longest continuous chain on the number of its carbon atoms. As shown on the screen, here the longest chain here is 5 carbon atom, so its root name will be pentane, as all the bonds between the carbon atom single covalent bond, so its suffix here must be end with ane. And here another example, my dear student, if you are going to choose the longest continuous chain here, so the root name is hexane, as the longest chain is 6 carbon atoms. The second point, the carbon atoms are given numbers in the longest chain, but here you have to mention one of the following rules. If the longest hydrocarbon chain free from any branches or side chain, the carbon atoms are given numbers from any side, left or right side. For example, here as shown on the screen, so 1, 2, 3, 4 from any side, and its name is called N-butane, means all the bonds here straight chain, so it will be normal butane. Here another example, here 5 carbon atoms, so it will be normal pentane. Here second point, here if the longest hydrocarbon chain attached to N alkyl group or any other atoms, the numbering of carbon atoms in the hydrocarbon chain begin from the side which is nearer to the branch, and the nomenclature begins by the number of the carbon atoms from which the chain arises, then the name of the branch, and ending by the name of alkane, such that, as shown on the screen, here 2-methyl pentane, as numbering of carbon atom starts from the carbon nearest to the branch. So it will be 2-methyl pentane as shown on the screen. Next example, here as shown on the screen, we have to numbering carbon atom for the longest continuous chain that nearest to the branch, so it will be 3-methyl hexane. Here, my dear student, if the side group is repeated in the hydrocarbon chain, we use the prefix di or tri or tetra to indicate the number of repetition. As shown on the screen now, here its name it will be 2,3-dimethyl pentane. Also, as here, my dear student, the branches at carbon number 3, so it will be 3,3-dimethyl pentane. If the branch, my dear student, is a group such as chlorine, bromine, nitro group, the name of this group is ended by the letter O, so we say chloro, bromo, nitro. As the following example show, here the name of this compound it will be 2-bromobutane. And another example as shown in the screen, it will be 2,3-dichlorobutane. My dear student, if the side group is different that alkyl group and halogen, here the groups are arranged according to their alphabetical Latin names, after numbering from the end that giving the branches the least possible summation. For example, here we have to numbering from the carbon nearest to the bromine atom, so here it will be 2-bromo-3-methyl butane. Another example here, it will be 2-bromo-3-chlorobutane. Another example, it will be here 3-ethyl-2-methyl pentane. And another example here, CH3CH and the bromine attached to carbon number 2 and ethyl attached to carbon number 3, so it will be 2-bromo-3-ethyl pentane. And here, my dear student, we have to start numbering to the lowest number of summation, so it will be 2-bromo-2-chloro-1,1,1-trifluoroethane. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today, so till we meet again, my best wishes for you.